Good morning. Thank you for joining us today for our Farm Foundation Forum, Creating Supply Chain Agility Through Data Innovation. We're happy to have you all here to engage with our panelists today. My name is Roggie, Fiddler, and I'm the President and CEO of Farm Foundation, located just outside of Chicago, Illinois. I am also a fifth-generation farm owner-operator from Nebraska and have had the opportunity to work throughout the food value chain over the course of my career. I have seen firsthand how data impacts the many stakeholders in the value chain, so I'm really looking forward to our conversation today. Before we get started, I'd like to, Morgan, if you can go to the next slide on housekeeping. Before we get started, I'd like to cover a few housekeeping rules. You can submit your questions by clicking on the Q&A button. Make sure it's the Q&A button, not the chat function. And when you're submitting questions, if you could please include your name and company so questions can be contextualized, that would be great. And due to our time limits, we may not be able to get to all of your questions, but we're looking forward to a lot of wonderful questions from you. So please submit them throughout our conversation. Just to note, the forum is being recorded and we'll post on our website on farmfoundation.org afterwards. If there are any connectivity issues during the forum, please just stay with us and usually it will stabilize. If not, click the link again to join. And when the forum concludes, you'll receive a short survey and we hope that you'll take the time to fill it out. So in terms of Farm Foundation, if we can go back to the Farm Foundation slide, please. I'd like to tell you just a little bit about Farm Foundation. We are an accelerator of practical solutions for agriculture, accelerating people and ideas into action. We are a 501c3 nonprofit with a portfolio of projects in 4 thematic areas, which really fit well with today's discussion. Those 4 areas are digital ag. The second one is market development and access, including supply chains. The third one is conservation and sustainability, and the fourth is farmer health. If you're interested in learning more about funding or partnering with us on any of these areas, I invite you to reach out to explore collaboration. And if you are posting on social media today, please use the hashtag you see at the bottom there at #farmfoundation.forum. You can also connect with us on any of these social media platforms or at our website, farmfoundation.org. So data affects every stage of the food and agriculture value chain. And on the heels of the supply and demand challenges of COVID-19, we are pleased to host this discussion today about the potential for improved use of data to impact all stakeholders. I'm excited to engage our excellent panel of speakers you see here in an important conversation, not only about the current challenges of data interoperability across agriculture, but also about the opportunities for suppliers and buyers to work together to create a more nimble and effective supply chain. We're grateful to have this wonderful group of speakers with us today. And our plan is for Ed Tracy, Larkin Martin, and Ranveer Chandra to share their perspectives first. And after these panelists have spoken, we're also pleased to have Farm Foundation's Roundtable Fellow, Rob Trice, with us to provide his reaction and comments. Farm Foundation has recently engaged with Rob on work around improving data interoperability, so we appreciate having him join the conversation this morning. But please note that Ranveer Chandra has let us know that he does have a family emergency, so he might not be able to join us, or he may be joining late. So in the event that he's not able to join us, Rob Trice will be covering some of the themes that Ranveer was planning on covering regarding the promise of innovative solutions for the future. We send our best wishes to Ranveer and his family, and we thank everyone for their flexibility this morning. So our first speaker is Ed Tracy, Vice President of Supply Chain and Sustainability for the Produce Marketing Association. With more than 37 years of senior management experience in logistics and supply chain management, for the last 10 years, he has been PMA's expert in developing supply chain practices to lead the produce and floral industries forward. He is also leading PMA's efforts to inspire the industry to implement sustainable business practices. So Ed, I'm going to turn things over to you now.
Hey, good morning, and thank you very much, Sherry. And if we could go to the slide that I created, which is the produce supply chain, or as I call it, the supply web. And when we're talking about data and sharing data and capturing data. One of the major challenges we have in our industry is with fresh produce, at the beginning of the supply chain, the grower and the harvester and the packer, they don't necessarily understand or know at the time that they're harvesting or packing the product of where that product's going to end up. And what we're challenged with today is each buyer or some buyers have a unique data requirement from their suppliers. And that's easy if you're in a consumer packaged goods environment or industry where their supply chain is fairly linear. Grow and pack, and it goes to a factory and gets processed and goes to a warehouse and then gets shipped out to the ultimate customer. Our challenge, and it is a major challenge, is that if everyone wants a slightly different piece of information accompanying the shipment of product that they're purchasing, how is anyone to know? I need to gather that data. I need to pass that data on to the next leg in the supply chain in order for them to send it to the final buyer or customer. On top of that, we're faced with a challenge of a challenge and benefit, but the challenge on supply chain visibility. People want to know everything about the products they're purchasing, and I'm talking about consumers. And they walk into a store with their iPhone and they want to have the expectation, and we built it, the expectation, not just produce, but overall retail, that they can scan something or punch a number in, and up on their iPhone or is going to complete, give them the complete history of that product, what the company stood for, what their, how they go to business, and how they treat the planet and the people on it. And that's a big challenge in our industry. Again, we're in a commodity environment. When we sell it as a commodity, and the consumers buy it as a commodity. There's not a lot of brand loyalty or specific requirements for only one brand of strawberries or lettuce. There are preferences when you see a certain label, but strawberry is a strawberry. People are buying the quality and the appearance of the product versus the brand name. And so, part of the data that is being requested from the supply chain is, firstly, food safety information. The buyers want assurance that they have a valid food safety certificate on file when they're purchasing from that shipper or the grower. And on top of that, and that's been a requirement for the last 10 or 15 years, and we're getting fairly comfortable with that, although that's done in a batch environment, if you will, where the food safety audits are conducted annually and they're shared with their known trading partners, the people that they deal directly with. And on top of that, we're now getting into sustainability and social compliance audits. And there's a lot of information being requested to be shared of how each company treats their people and treats the planet, and being validated through various sustainability audits. Again, that's done primarily in a batch environment where it's sent annually, and the buyers check the box and ensure that the score or the overall score is to their minimum acceptable level, or if they're a little more sophisticated, they look at section by section, make sure that the right answers are there, both on the food safety and the social compliance and sustainability odds, so they can be sure that purchasing product from that supplier is not going to put their brand at risk. Again, it's a challenge because you don't know where the product's going to end up ultimately. Private label, yes. You know, if it's you're packing a private label product, you know who the customer of that's the easy part. The challenging part is as the product goes through this, I call it supply web versus a supply chain. There are various stops along the way for some products, and not every product travels the same path, and the same products don't travel the same path through the different regrading and value added and different steps. And trying to gather information and tie it to the product that's going through the supply chain is very, very difficult. So on top of that, food safety and sustainability information, we're now going to be faced with additional information that we never shared. If the proposed rule for record keeping for trace foods FDA a final rule, you're now going to have to gather information and share information around your cooling and harvesting and growing, as well as who the person who assigned the lot number and their contact information, and the harvesting, cooling, and packing information to our first receiver beyond the farm, and the information in addition to the lot number of that lot number needs to be carried with the product all the way through to the final retail food outlet, restaurant, cafeteria, grocery store, convenience store, online fulfillment center. And that's the level of data sharing we've never accomplished or even considered until we saw that proposal from FDA in September. And then we're seeing more and more initiatives of companies wanting to get full supply chain visibility, because you can imagine any potential paths that a product can take from harvesting to consumer, that they want supply chain visibility information, and it's very difficult gathering that information as the product goes through the supply chain. And then we're seeing different buyers require different types of information. One of the initiatives that is spurring, helping, and challenging the industry is the blockchain applications. And there's a number of companies who have created blockchain or applications, supply chain visibility applications using blockchain to secure and encrypt the data. On supply chain visibility, one of the benefits beyond seeing, as in real time and time stamping how product is going through the supply chain, you also get traceability as a byproduct. So if you're doing supply chain visibility and
sending all the right data from sensors and activities at the critical or critical tracking events. You can see how the product's going through the supply chain. You can understand where it's not moving at the right time, speed, or temperature, and you can take corrective actions. Those applications are very valuable. There's great information being gleaned from them. And as I said, as an addition or a freebie, you get very, very good traceability. Go to the next slide. And I've been involved with the Produce Traceability Initiative for over 10 years, my entire tenure with PMA. And working with Rob Trice, one of our speakers, he and I have had many conversations on data interoperability and how do we solve this and how do we get our heads around and make it easier on our supply chain to gather and share the right data efficiently. And I've talked about food safety and sustainability audit information and sending that annually. One of the challenges with that is the buyer does not know that the lot of product received this morning from their supplier, that actually lot of product was subject to a valid food safety or sustainability audit. They have an annual record, they have an annual audit, and they assume that that audit is in place for this lot of product. What I'm seeing on the verge right now, and a number of companies are looking at this, and application providers on supply chain visibility, is the desire to marry the two. So when you're shipping me the product, I want to know about that product. I want to know where it was grown and harvested, and I want to know which audits are in place at the time that that product was grown and harvested and packed. And we're scratching our heads of how to accomplish this. And I came up with this very simple graphic. And my concept is, and one of the things we need to do is standardize the attributes or the information that each leg in the supply chain needs to gather. And using blockchain technology, the data can be secured, which will ensure it cannot be altered, and it can be linked to the next step in the supply chain, as well as you can put permissions of who can unlock and view the data. And one of the beauties with blockchain is you may have a copy of that, for example, in the middle of the transport company. The grower has his ledger and his information and the audits and information around that lot of product and what, the applications he's put on, whatever data he chooses to share, he puts it into a ledger using blockchain encryption, passes it on to the packer shipper. They then add their information and link it to the grower's information, and then it goes over to the transport company, and he may have and will have the grower information and packer information. He adds and links his information, what he's done to that product. But if he does not have permission, he cannot look at the growing or packing information. He can have it and he can move it forward and link his data. So that's one of the benefits of using technology like blockchain, and I'm sure Rob can explain a little more detail, and how we make this data interoperable. But my vision of the future in our industry is, given that you don't know where the product's going, and there's more and more data being required from you, and the ultimate buyer is under pressure, one, to view the entire supply chain so they can have visibility, so they can tweak it and make sure that the product is moving through the supply chain at the right temperature, at the right time, at the right speed. Is if we can agree to the attributes and the data at each stage in the supply chain that need to be gathered and shared, there is a technology out there that will enable that. And in this example, the grower or the packer, if they don't know where that product's going to ultimately end up, because the point in distribution may be a wholesaler and they have various customers, whoever buy from them that day, the required information can accompany the product. And I'm predicting that that information is going to increase in value to the ultimate buyer. One, you get assurances that all the right audits and information and what's important to your company and your brand, that product satisfies all of your requirements, and you've got all the data about the product when the product arrives at your facility. So it's not an easy road to go down, but fortunately for our industry is we have technology that will enable this. And so we've got the tools that will help us share the data and will help us secure the data and will assist in only ensuring the appropriate permission people are able to unlock and view that data. The big challenge is which data, and there's the IDEA consortium that Rob Trice is heading up, I believe, is trying to address that problem. So I'll stop for now and turn it over to Larkin, and I believe she's going to continue the talk and give us more examples of all the data that a producer, grower, farmer are required to capture and share.
Thank you, Ed. In fact, we did have some good questions coming in while you were speaking, and just to let people know, we'll come to those questions. Thank you for submitting them. We'll hear from our other speakers first, and then we'll come back to the questions during the Q&A time. So as Ed mentioned, our next speaker will be Larkin Martin, CEO of Martin Farm in Cortland, Alabama. Having worked on the farm and across the food and ag value chain in a variety of directorships and executive positions, Larkin brings a wealth of direct experience to the discussion today around the importance of data from the farm gate forward. Larkin also is the current chair of the Farm Foundation Board of Directors. So over to Larkin.
Thank you, Sherry. Hello, everyone. I'm going to sort of divide my talk today into two parts. The first part is going to be a field trip through one of our crops, hoping to illustrate the current use of data and the opportunities to improve it. And then we'll go into just sort of the farmer problem around data. Ed did a great job of framing the data issues in the produce supply chain and all its variability. And I'm going to just start with this field trip through one crop, and it's cotton. How does it go from the picture on the left, the field, to the textiles that we buy in a store on the right? What are the steps, and where is data attached, and where is it available and not currently being managed in the way it might be? And in the case of a cotton producer, we know a lot more about the data required by the buyer than Ed mentioned, that being a struggle in the produce industry. But there really is a lot more visibility that could be available to the full textile supply chain with new technologies. I chose cotton because of the crops we grow, and that's corn, soybeans, wheat, and cotton. Cotton is unique in its that data gathering and management opportunities. So for those of you not familiar with the cotton supply chain, let's take a quick field trip and pictures through the process. The next slide is the harvest process. So rating left to right, top to bottom, there's a field of cotton ready to be harvested. There's harvest in process in the top middle slide. And what you're seeing there, the cotton harvesters, the process of harvesting cotton, that has to be contained, picked off the plant, contained in the field, transported to a gin where the cotton is processed further before it's marketable. So in the field, the cotton is harvested and packaged into compressed transportable bundles. There's several kinds of systems for these bundles to be created in the field. But the image you're seeing here is a harvester that actually puts the cotton into rolls and puts plastic wrap all the way around them. Watch this thing, it's like watching eggs being laid in the field. The harvester just keeps spitting them out. The farmer then moves these rolls to some sort of collection point at the edge of the field. And the farmer has an opportunity here to organize these rolls any way they want, or to ignore organization and just get them out of the field into the edge, where the next step is for a truck to come pick them up and move them. The truck moves them to a gin yard. That's the picture you see on the bottom right. You'll notice in that image, which I found on the internet, and I hope I don't have a copyright problem for putting it in my slideshow, there are lots of different types of these in-field storage system. You see large rectangles in the foreground in that picture. You see the rolls that are illustrated in the rest of the slide. Further in the back in that image, there's some large rectangles and small rectangular storage systems. So the gin has to manage different containment sizes and forms in its yard and its transportation mechanisms. But in a general sense, cotton is moved from the harvest to a point either close by or far away by truck and reassembled in groups, and then it waits its turn to be processed by an industrial facility. So at this point, it's called seed cotton, because included in the fiber are all the seeds and sticks and leaves that are left over as part of the harvested product. So if you go to the next slide, these are illustrations of the cotton ginning process. So again, top left to bottom right, the lumps of seed cotton in whatever shape and form they're delivered by the farmer are picked up in their turn on the yard and unwrapped and processed through the gin. And it's a continuous flow operation. The gin sort of mechanically uncompacts them and puts them in a little bit fluffier state. You can see the conveyor belt taking the seed cotton in. There's the bottom left picture is the gin stands, Eli Whitney's invention in modern form, where the seeds are being removed. But at the end of the process, in the middle slide at the bottom, out comes this cleaned lump of pure fiber, hopefully very pure and very white, but they're grades that make it, some cotton's not as good as other cotton, highly compressed, strapped up and wrapped up. And on the bottom right, you have this almost infinitely storable 500-pound lump of fiber available for sale. At this point in the cotton stream, the industry has a good system, at least the US industry. A bale identifier number is attached to each one of those 500-pound lumps. And from this point forward, that bale identifier number is sortable and recognizable by software systems in the subsequent steps in the supply chain, the merchant, the textile mill, and attached to each one of these bale identifier numbers are a series of grades. So if we go to the next slide, and it will make you dizzy, don't panic, and you don't even have to read this. It's a sea of numbers. This is a screenshot of one small section of my grade report from my gin from last week. Each line of data represents the grades, information on one bale of cotton. So if you have, let's use simple numbers, if you have 2,000 acres of cotton and your yield is 2 bales per acre, you will have 4,000 sets of these numbers across the line in your, made available to you probably in a paper printed form if you're the grower. And with really, except for visually scanning it, not a lot of ability to understand what it means, but it means a lot. If you look at the blue highlighted column, again, doesn't matter, but these are all these industry standard unique bale identified numbers. And so if you read across, There's information about the field it came from and all the different grades. There are grades about the fiber diameter, the fiber cell wall, thickness, the length, the strength, the uniformity. If you go to the far right column, highlighted in yellow, again, don't worry about it. These are either premiums or discounts associated with the fiber qualities of each of these bales. You can't probably see it on this slide, but I have highlighted, and these are premiums and discounts associated or announced by the USDA loan. So these are premium discounts if you were to put your cotton in the loan. But in this one screen capture of one particular report I got, our farm had a difference of a 4.5 cent premium on one particular bale or a 1.25 cent discount on one particular bale. Now, if you go through the math on that, that's at a 2 bale yield, a penny difference is $5 a bale. That's $10 an acre on a 1 bale yield. On a 2 bale yield, the range of variation I've got here is $56 an acre in value of my crop off the same acre with the same yield associated with fiber qualities and fiber properties. So it's an underappreciated area of management opportunity for cotton farmers, which is this premium and discount schedule and understanding agronomic practices, harvest practices, defoliation practices that improve your chances of getting premiums and not discounts. We can't stop it from raining, but what can we learn here if we had the systems to analyze it? It's pretty significant. If you go to the next slide, this is the textile mill. This is the next step in the process. So those bales you saw on the bottom right in the warehouse, those are bought and sold by third parties. Most of the cotton in the world is traded across oceans. A lot of the spinning into yarn is done in parts of the world different than where the cotton is grown. But at the spinning mill, top left-hand side is what they call, I think, a laydown room. And a textile mill sources cotton however they choose. And they open up those bales, take the straps off of them, and then and put them in a big long line, and a vacuum cleaner-like device goes over and back and forth across the top of them, vacuuming up layers across multiple bales. So a textile mill has an opportunity, and they make these choices in their laydown room of exactly which bales with which fiber characteristics to put in any particular batch that they're sending into their process. The rest of the images are just processing of raw fiber into the yarns that are then used, woven or knitted into fabrics that become textiles somewhere in the world, just to illustrate that they, again, have a continuous flow process, and any textile mill is challenged by taking a variable natural product and turning it and having the machines run efficiently and fast into a uniform product for sale. So there's the process. That's the cotton field trip. Now let's go to the next slide, and we're going to go back to the beginning. Top left image is a yield map from one of our farms this year. It shows you we have huge variability. We have rolling land. This has been a good year. Overall, that field was over 2 bales, but the red areas, they were under 500 pounds. And the green areas represent 2,000 pounds per acre. So you can see the field was harvested east to west, that as the picker goes across that field, it's going over good and bad areas in a single row multiple times. All right, the simple diagram on the top right, I drew with, and apologize for the cartoon-like appearance of it, but it's to illustrate that and we use the round roll harvester system, as those rolls are created and deposited by the picker all over the field, the picker with that technology, or that particular picker has the technology for RFID identification on each roll. It's possible, the technology exists for a fee a grower can enable it, but at the moment, it's not broadly utilized, and the advantages it could bring are not being realized. What happens now is the grower, we take those lumps and we organize them however we want at the end of the field, but we pay really no attention to what order they're stacked and ordered in. They're just designed for the truck to come pick them up. And on the gin, the same thing happens. They're put down in maybe the order they arrived. Maybe one grower's inventory is in this area and another grower's inventory in this area, but not a lot of thought by most farmers or gens about how that's managed. And we're losing the opportunity to gather agronomic information about what ultimately matters in this textile mill on the far right about the agronomic properties of those bales. Now, if a farmer could understand the grades they got back from a certain section of the field, or a certain variety that was planted in part of a field, or a certain soil type that you were harvesting over, and could then respond with changes in their own practices. Remember that $56 an acre difference in fiber qualities? If you can make choices that improve your chances of getting premiums instead of discounts based on, and think about what artificial intelligence could do with all the volume of grades throughout all the country, how much we could learn about conditions that improve or disadvantage the fiber. In addition, if this information was made available through some sort of blockchain technology like Ed discussed, the traceability, not just from the gen point, the gen and these bale identifier numbers tell you the grower, they can tell you the field something came from, but the linkage of grower information, should they choose to share it with a textile mill, could validate all sorts of claims around agronomic practices and traceability. Carbon sequestration processes could be validated. Sustainably grown claims could be validated based on grower records of field practices. It would all be enabled if the grower chooses to engage in that sort of marketing opportunity in the textile, within a link with a textile mill. But for this industry to link information from the field production system to a bale and make it available to farmers and to the supply chain, there's going to have to be improved data management systems at cotton gins. And now, why is this not happening yet? Well, the harvest systems allowing the RFID location information to be assigned to the module is relatively new. So we're talking about new opportunities. But primarily, the gins, which are typically locally owned and thin margin businesses, they're scattered geographically and idiosyncratic in their ownership and histories. Few to date have had the market demand or the operational incentive to develop the complex software systems that would be required. I have an involvement with a gin, and we've explored this, and the answer I've gotten is from software developers, well, there just aren't enough gins to make it worth an investment. It's going to be too hard to, and there's not enough people to buy it. There are not enough gins. So one of my principal reasons to go through all this is to make the point that when we're talking about some of this sophisticated data management, it is a problem for this specialized software to be developed for smaller, unique segments of the agricultural supply chains. If you're investing a lot in R&D for development, you're going to want a return on that. And if the potential audience or users of your system is beneath your desired size, you don't spend time on that project, and you move to one with a bigger audience. And that, I have no idea what it is in cranberries or walnuts or anything else, but for cotton gins so far, there's not been an interest in developing this system broadly. So challenge the audience to recognize that and think about other places where smaller specialized agricultural industries might be ripe for additional software development, but it hadn't happened yet. And speaking of small and unique and idiosyncratic, let's talk about a farm. Next slide. All right. This slide is my attempt, and I've used it in several settings and enhanced it a little bit for this talk. It's my attempt to illustrate the complexity of the needs of software and data management on farms. Farms need ERP systems. They're not generally available. And data interoperability, as has been mentioned already, is a problem. So on this slide, I try to categorize the types of data that our farm manages in boxes, and they have headings. So the top left blue box is the GIS, GPS sort of information. It's spatial data. So that's field boundaries, planting boundaries, applied where inputs are applied during the year. It's certification maps, it's soil maps, it's Verus maps. It's all sorts of spatial information that helps us know what happened where in a field on an annual basis. There's also business data that we manage. These are land leases, loans, crop insurance data and yield histories, input purchases and pricing, sales and marketing contracts. You can read the list as USDA reports, USDA program participation records. You all can read that as well as I can. Underneath it, the other small boxes, huge category lumped here into one thing, equipment and truck management software. All the machines in the fields, the transportation that we're using to move crops around from field to store on-farm storage and out. There's all kinds of software for that. Can't even see the next. Grain flow and management, sensors in our grain bins, sensors in all sorts of places that tell you how much you have of the crops you're producing. All this data is coming into it's available, but the formats differ, and organizing it into useful information, I distinguish between data and information, is very difficult. And in some of these cases, a lot of these cases, and you'll see these ovals throughout my slide, the ownership of this data, if it's being gathered by a device that you've purchased or leased, and it's being transferred from that data or device through to a software system, that transfer process and who captures and owns it is something the industry is struggling with and a lot of conversation around. On the right-hand side, similar illustrations. You've got your custom applicators, other parties, not your own machines, may be doing things and sending you data or not sending you data, depending on your relationship with them and your request for the data. You've got all sorts of consultants trying to use maps and send information and maybe prescriptions coming back and forth to a software system. Other gray sort of box with rounded corners, all sorts of third-party stuff. You've got drone data, satellite imagery, sensor data in the grounds for moisture management. It's similar in my mind to a hospital or a doctor's office where the patient has blood pressure readings, x-rays, all sorts of other kinds of information that the doctor has to assemble to understand the conditions of the patient. A farmer has an enormous number of incoming information that they then need to process to manage their decisions effectively. And then the green boxes are the kinds of things that you would want a system to spit out. You would want a system to be able to spit out, in the case of the GIS data, ways to do things differently in the field. Variable rate applications and all sorts of opportunities there come with the information that you've processed. Any number of reports, I don't even try to list them all, could be generated that turn data information for all sorts of sources, and you can read the list there. I'm only posing the problem. I'm not posing the solution. I'm hoping that Rob or other speaker is available and they can help us solve this. Broadband access is down there at the bottom because very little of this works if broadband is not available. And that's a problem in our rural communities. We all know that. Cloud-based systems and who owns them and manages them, or farm-based systems is a struggle. But I'll make some sweeping generalizations before I close about some of the issues here. Today, most of these parts of this web are being solved by apps or systems designed for one purpose. There's very little software out there that brings those disparate apps into one interoperable platform. So my hope is that we will, as an industry in agriculture and farms in general, will over time, platforms will be developed that are designed to aid the farmer and the farmer's business. Today, software is often provided, but these apps are intended, I think, too often to harvest data from the farmer, and the flow of information is too often one way. It's from the farmer outward. The app may be free, but what's being gathered by the app has value to someone who provided it. And it's my opinion that I don't believe any farm should feel completely comfortable if an ERP system is supplied by a company that is a significant counterparty for their business, either for machinery or inputs or sales, because by definition, their interests are not aligned. GM would not buy their ERP system from the steel mill that they're using. Here's the problem. Farms, like the cotton gin described earlier, they're scattered, they're idiosyncratic, they're different agronomic practices, business structures, models, lease structures, even those raising the same crops. And so developing a platform both robust and nimble enough to work for all, or even for many, is a challenge. And getting farms to pay enough to return a profit to the developer is also a challenge. So the motivation for developing farmer-focused, farm-focused business software, it's a difficult economic proposition. Farmers have gotten used to having things for free or nearly free. Well, the free part I would question in the long run, but in the short run, it sounds a lot better than paying a lot of money for a software system. So I think that's an industry-wide discussion. I'd like to hear what the future speakers say about it. In my office, we're most recently excited about it's a Microsoft product that I've learned about in the last 10 months called Power BI. And I don't know anything about software, but I understand it's a tool that helps bring together information from multiple sources in different formats into useful and graphic reports. So I hope our next speaker from Microsoft has been able to join us. If not, I hope Rob can tell us more about that. I want to be positive at the end of this because I think the opportunities are huge. And I'm excited to hear what others think we can do about it. Thank you.
Thank you, Larkin. Our vision for today was to look at this through different lenses. And as a corn and soy farmer myself, I love the chance to see it through the lens of your cotton operation. And there are a lot of similarities of our needs. So I think that was very helpful to see. And before we dive in here with Ranveer, can we just check in, Ranveer? It looks like he has been able to join us.
Yeah, hi.
Sure we can hear, great. Thank you so much for being with us. And thank you, Larkin, for those remarks. So before we transition to Q&A, we're delighted that Ranveer Chandra has been able to join us. He's Chief Scientist at Microsoft Azure Global, where he leads research and innovation across different industry verticals. He started the FarmBeats project in 2015, which shipped as a Microsoft product in 2019. And as time permits, Ranveer, I watched SpaceX over the last couple of days, and if we get to weave in any of that and the data interoperability there and lessons learned, that would be cool to do as time permits too. So Ranveer, as I said, delighted to have you with us, and over to you.
Thank you, Sherry, and thank you for the previous comments. The previous speakers have done a great job laying the foundation for what I'm going to talk about. So I'm Ranveer Chandra. I've been with Microsoft for 16 years, and my background is not in agriculture. I'm a PhD in computer science. I did my PhD from Cornell and joined Microsoft Research right after that. And at Microsoft Research, I've been building various tools for connectivity, for data, using AI, all cutting edge stuff we publish in the top tier computer science conferences. And then in 2015, I started this project on FarmBeats, which actually goes very well with the last slide that Larkin had, where we bring together different data streams from the farm, from different sources, bring them all together to start providing insights about what might be happening in the farm, what might be happening in the entire supply chain. And with FarmBeats, we try to address some of the very fundamental problems around data acquisition. How do you get data from the middle of the farm? That's one of the challenges we address. Then once you get this data from different sources, for example, from the farm, the geospatial layers, the sensor data, the drone data, the satellite data, all at different resolutions, how do you make sense of it? So then we combine them, add the layering, build the data cube, and then combine that with AI so that you can then start bringing the benefits of artificial intelligence to your data. So before I go there, just wanted to say that I'm very excited about this topic of using data. That is, right now in my current role, I'm working across different industries, not just agriculture. And what I've seen is that all the other industries are way ahead in using data to improve efficiencies, to improve profitability. Agriculture, of course, is a much harder industry, agriculture and food. And it is great that now we are all discussing about how can we bring about this digital transformation? How can we bring the benefits of data to the grower, to the agricultural companies, to everyone involved in the food supply chain. So the key idea here is that we saw some of the examples, for example, the one that Ed talked about and Larkin in the context of cotton. If you have data about what's happening in the farm, you could then enable technologies like precision agriculture. And precision agriculture, as we know, helps reduce cost, helps improve efficiencies. It's also better for the environment. For example, you would use less water, less pesticide, less nutrients, and so on. In fact, it's not just about production ag. Every component in the food supply chain would benefit from data. Food processing companies, logistic companies can route their trucks better. Everyone would benefit if they could get data, if they could get the data from their operations and use AI, use predictive analytics, use Power BI, the tool that Larkin was mentioning, to improve efficiencies of their own operation. But it just doesn't stop there. It's not just about each organization using the data to start benefiting from it. If every organization, if every component in the food value chain can share that data across the entire food value chain, you can then start unlocking new efficiencies on top of that data. Like, for example, we heard about some of these scenarios, like for precision agriculture or for seed companies. If they know what a grower is doing, they can then use it, or how the crop is performing, how the seed is performing in the farm. The seed companies can develop better seeds. Similarly, logistics companies, if they know what's happening in the farm, where the crop is stressed, what's happening there, they can do better. Ag finance companies, if they get data throughout the supply chain, they can of course do better. Farmers would benefit from it as well. And of course, with all the latest talk about outcome-based farming or sustainability, where if you could market a product as sustainably grown, how the food was grown, how it was processed, you can then convey that value to the consumer, who would probably pay extra for that particular produce. So all these are benefits, which are all awesome, right? Then why hasn't it taken off? We heard about some of those challenges. In particular, Larkin mentioned in the end, one of the key challenges is data. How do you just get data from different parts of the supply chain? The farmer's house might have some sort of connectivity to the internet, but the farm itself is far away. Many of these farms don't have any internet, leave alone broadband. So then, how do you get data from these remote places, from the middle of the farm, from drones, tractors, robots, whatever it is, sensors? How do you get data from the middle of the farm to the farmer's house? To address this problem, we use one of the technologies that I had started working on right when I joined in Microsoft in 2005, called the TV white spaces. What the TV white spaces enables is, imagine if you had a Wi-Fi router and you could access it a few miles away. That would be cool, right? Right now, as soon as you exit your house, your Wi-Fi disappears. And the way we did that was we took a Wi-Fi signal and we put them in empty TV channels. This is TV you watch using over-the-air TV, you watch using antennas. You know, when you browse through TV on certain channels, you get a transmission. On the other channels, all you get is white noise. The key technology we had developed back then was a way to take a Wi-Fi signal and put it in a noisy TV channel in a way that doesn't interfere with your TV reception in an adjacent channel. So you could be watching channel 7 at home. On channel 8, we could be sending Wi-Fi signals. And back in the day, the FCC chairman had come in 2010 to see the demo we had put together on Microsoft campus, and this was made legal in the US. In fact, 2 weeks back, the FCC modified the rules to make it even better for rural areas. That is, outside of cities, the FCC is allowing much higher transmit power. So what you can imagine is Wi-Fi that can go about 20 miles. And the interesting thing about agriculture here is that TV towers are where people are. You have TV towers in San Francisco, in Seattle, in Chicago. The farms are away from the cities. So if you turn on a TV in the middle of a farm, most of the channels are just white noise. And the more noisy channels there are, the more available spectrum there is. So this is one way in which we can bridge some of the broadband gaps. We can then use this to get data from different parts, from the farm, from the grain silos, from different parts of the food supply chain. You can start bringing the data in. Now, of course, all of this data doesn't need to get to the cloud. Another new technology that we're working on is edge computing. That is, you don't have to send all of this data to the cloud. Some of this data just needs to stay in the farm. the farmer might not want to share the data. Or this is just huge amounts of data. Like if you fly a drone, in like a 15-minute drone flight, you could have a gigabyte of data. Sending all of this gigabyte data to the cloud will take a really long time. So to address this problem, what we use is edge compute. Imagine a computer sitting in the farmer's house or office, doing a lot of computer vision, a lot of artificial intelligence sitting in the farmer's house itself, so that you don't have to send all of this data to the cloud. This new trend is called edge computing. So TV white spaces along with edge compute can help bridge some of the broadband issues that Larkin pointed out towards the end of her talk. The other challenge is once you get this data, what do you do? It's not just about one data stream. Artificial intelligence right now, people usually talk about, you know what, if I get data, I can do predictive analytics on that data. But what if there are different types of data coming in? You have sensor data, you have drone data, you have satellite data. So there is this new thing coming along called multi-modal learning, where you can then combine all of these different data sources to add insights. One of the things we did as part of FarmBeats was, if I have a few sensors in the farm, how do you build a map? What is, say, for example, the challenge was, what is the soil moisture level 6 inches below the soil throughout the farm? You can't put a sensor every 10 meters to get that soil moisture map. What we did was we used artificial intelligence. That is, you intelligently put a few sensors in the farm, then you use aerial imagery, either from drones or satellites. Wherever you have a sensor and you have an image, not just RGB, but multispectral or hyperspectral imagery, you use that to train a machine learning model. And then you use that machine learning model to predict these values in other parts of the farm. And we then, in a research paper we wrote, we showed that this technique of combining different data streams using AI can be up to 3 times more accurate than existing schemes that just use the sensor data without using the aerial image. So this is just one example of AI. There are many benefits that AI could bring. For example, if you start combining data from the different data streams, for example, from the farm, from the logistics companies, from different farms, bringing them all together, there are these new things called federated learning, where you could be training the model across all of these farms to start making very hyper-local predictions of what might be happening in the farm, so that you can tell a farmer when to plant, when to water, when to harvest, when to do what, where in the farm, is something that artificial intelligence could enable. Now, this is about still at the farm level. What do you do once you start getting this data? What more can you do with this data? How do you even share this data across the different entities? Because one of the challenges that was pointed out was, well, who owns the data? Where does the data go? Who's allowed to access the data, and what are they allowed to do with it? So there is some new concepts coming up called blockchain. Of course, many of you are aware of it. At least it's a buzzword. Many of you have heard about blockchain. But underlying blockchain, there are some key, very interesting concepts that are being developed in computer science. That is one of these things which we've built is called confidential compute. What this allows you to do is, so the problem is the following. That is, suppose I want to share data with Shari, right? I would encrypt the data, right? And then, but this data, Shari has access to the entire data, like, because she'll unencrypt it. And when she does compute on it, the entire data is unencrypted. So she has access to all of my data that I'm providing to her. What if I wanted Shari to do some computation on this data, but did not want her to see the raw data itself? For example, you want to provide data to a seed company and say, hey, you know what, you can do aggregate analytics, but I won't tell you what I did row by row. Now, how do you enable these kind of computations? So there's this thing which we built called confidential compute. What that does is it leverages hardware level encryption so that the data is never decrypted. It's in hardware and all the processing. So no one has free access to that data. Only certain computation is allowed on that data. In fact, in more recent work, there's another work at Microsoft Research that is done on a new technology called homomorphic encryption. What this says is, even when the data is encrypted, you could start doing artificial intelligence on top of this data. So these are new ways of sharing data where you can start bringing data together, enabling people to share data while knowing that this data is not misused. Only what the operations that you allow are the ones that are allowed on that data. And in fact, the other thing we are doing as part of edge compute is once the data goes through this computer in the farmer's house, the farmer can decide what data goes where, so that the data is either staying in on the computer itself, or decides which cloud, who has access to that data. So these are all important questions, and we are still at the initial stages. But what we are doing is building all the mechanisms as part of the toolkit, so that agricultural companies, food companies have all these tools available to them when they start thinking about what do I do with this data, how do I share the data in a secure, privacy preserving way. So that's some of the things we are doing here at Microsoft. We've, of course, announced this product called Azure FarmBeats. What Azure FarmBeats does is it's not meant to be a grower-facing solution. It's meant to be for other ag tech companies, where we address some of the problems I just talked about. How do you get the data? How do you do AI on top of different types of data streams? That's some of the things we are addressing, and we combine that with AI tools, enabling ag tech companies to build their AI solutions on top of this. At Microsoft, we are, of course, taking a much more holistic view. I talked about research, the new cutting edge work we are doing in the research space, some of the product work around, I talked about some of the work around blockchain, around confidential compute, Azure FarmBeats. We are doing work on the Internet of Things, which is about how do you get data from different things out there. Where Internet of Things, I don't know how tech savvy the audience is, but if you think of the Internet right now, it's designed for humans primarily. It's designed for us using a phone, using a computer, where most of the data is usually downlink. That is, you're downloading data, you're watching Netflix, you're watching YouTube. The next version of the internet is going to be a lot, which also has to support things. These are sensors, these are your thermostats at home, these are your cameras, like what we are doing now as well with Zoom, sending information up, where the data flow could be different. And how do you build such an Internet of Things? And there's a lot of work happening in that space. We at Microsoft have a tool called Azure Iot, which allows you to bring all of this data together, do AI, artificial intelligence on this data in real time. So while we're doing that on the product side, we are also doing work to take all of these innovations and try to complete the loop, even though we are not an agricultural company, through some of our work on CSR initiatives, on corporate social responsibility. Some of the work we're doing that, one of them is Airband, through which we've made a pledge to connect 3 million rural Americans to broadband by 2022. We are partnering with other ISPs, with ag tech companies, and trying to bring broadband to rural America. In another work, we made this announcement on our sustainability initiatives. Earlier this year, Microsoft made a pledge to be carbon negative by 2030. And as part of that, what we mean by carbon negative is we'll put back more carbon than the amount that we generate. So the way we'll get there, of course, is part of it is through reducing our emissions. But the rest of it, the way we'll get there, is through techniques such as agriculture and working with growers, working with the ag tech companies, so that more carbon is put back to soil. And in two other things I'll point out there. One work we're doing is with the FFA, with the Futures Farmers of America. One of the other challenges, which Larkin didn't mention, but I think she implied in her talk, was that growers are not that tech savvy. So how do we get them to know about data, to know about data-driven agri-food systems, to know about AI? So what we've decided there is to start young, to work with the FFA, to work with 4-H. What we've created is a FarmBeat Student Kit. We just announced a new version of that at the FFA convention last month, where this is a kit which we give to the FFA high school chapters. We work with them to create a curriculum. And then our goal there is to get these the students, while they're in high school, these future farmers, to know about data-driven agriculture, to know about AI, to know about the different tech tools that they can use as part of farming. And the last thing I'll mention is some of the new work we are doing with universities. There's this work that we did with Purdue University, Professor Jason Lusk, who's the head of Ag Econ. Sorry, I'm at the airport. If you hear a background noise, it's just at the airport. They are playing a jingle. So the work that we did with Professor Jason Lusk was on identifying food and ag worker risk in the ag food supply chain. And the way we are doing that is we got data from different data streams, from JHU COVID data, from farm data, from USDA. We brought all of that data together, and then we are doing AI on it and presenting that data in a Power BI dashboard. This is the dashboard that Larkin talked about, where you can go and click for any commodity in any state. What is the food an ag worker risk. So some of the things we were able to do was, for example, we were able to flag that a certain packing plant, meat packing plant, was going to close a week in advance. So these are some of the things we are doing across the entire food value chain. To summarize, the future looks bright. A lot of technologies are still being developed. They are being adopted by other industries faster, but agriculture poses some very unique challenges. And we are very excited about working with all of you on helping address some of these problems around data collection, around artificial intelligence, around data sharing. So really excited about this opportunity and look forward to answering your questions.
Great. Thank you so much, Ranveer. You have the power of concentration in an airport with the background noise, so thank you. And it's great to get some idea of where the solutions are headed. We all know and feel where the problems are, but it's great to hear where some of the solutions are headed. So before we open up for Q&A, we've asked Rob Trice to step in and do a couple of things, Rob, if you will. One is to give you the chance to respond, react, or riff off of some of the other speakers and things that they have said, but then to also comment on some of the work you're doing in data interoperability. And as we mentioned before, Rob has a few hats that he wears. He's the founding partner at Better Foods and also the founder of Mixing Bowl. Excuse me. And he works quite intensively in the data interoperability sector and adds another lens about sort of looking through the animal protein lens with data interoperability. So Rob, over to you.
Thanks, Sherry. And I can't say enough about the panel that you got here. I've been learning from Ed Tracy, I think, since 2014, and Larkin, every time you speak, I learned something new. I appreciate the walk through the cotton fields this morning. And Ranveer, I actually had the opportunity to listen to you at the University of Minnesota Ag Data Revolution conference. So I was excited to have an opportunity to hear you a little bit more today. Just to build on what Sherry was saying, my background is about 15 years in the mobile internet telecom space. I focused on food and ag around 2014 and started two organizations, the Mixing Bowl and Better Food Ventures. Better Food Ventures makes investments in companies applying information technology to food and agriculture to make positive impact now. The Mixing Bowl is more for thought leadership and action that can result by connecting IT, food, and ag innovators. So if I look at this, I think one of the big learnings that I've seen in this space is exactly what you guys are talking about, which is we have siloed data in food and agriculture. And to Ranveer's point, we're farther behind other industries. Having come from other industries, it sometimes feels like those days back when you couldn't open a Word doc on a Mac computer in agriculture. And in fact, one of the things that really spurred me on was I was at a dinner with a handful of farmers out in the Central Valley, California. And we just said, let's put venture and incubators and all of that exciting stuff aside. What problems can we solve for you? And we went around the table, talked to these farmers, and almost to a T, they all mentioned this siloed data is an issue. One of the farmers there had 42 different data dashboards. His irrigation system didn't talk to his John Deere system, didn't talk to his ERP system. And another one complained not about the regulations themselves, but the burden of reporting on regulations. So in their farming operation, they had, in their headquarters, they had 30 people focused on farming operations, 37 people focused on reporting. And this is all because we have different forms and requirements for reporting. So at any rate, if I kind of summarize what I heard today, well, actually, I'm going to back up. I'm going to talk a little bit about why I've stepped up and kind of really wanted to get into this, because I think if we can get this interoperability going, I really do think selfishly, it's going to go create better investment opportunities to digitize food and agriculture. I see right now a bunch of different startups that all have different languages, but there's no translation table. They can't speak one language to another, and we need this desperately. So about 6 months ago, I started a group called IDEA, Interoperable Data to Enhance Agriculture. And fundamentally, what I wanted to do was bring the people that are working on interoperable data in food and agriculture together to interoperate. Because right now, even those interoperable data groups have been by and large siloed. And so how can we actually all put a shoulder and lean in on the same direction to raise awareness and go solve problems. And I'm pleased that we've actually started working with the Farm Foundation. And in fact, last Friday, we had a great event with about 50 folks from across the pork supply chain. And I think Andy Brookall from the National Pork Board may be on. He was a sponsor of this event. What we did with the Purdue Open Ag Technology Systems Center and the Farm Foundation, we actually did an event storming where we mapped out the entire pork value chain. And from that identified areas, we're going to roll up our shirt sleeves and go solve some problems. So we need more of that. We need people looking at how we can solve these problems. If I look at what I heard today, I kind of look at 3 different buckets of areas. I heard on one hand, we're making good progress on data collection from the field, whether that's an RFID tag, a QR code, cheaper sensors, aerial imaging, or aerial sensing, if you will. All of those ways to collect data from the farm, we're getting there. Broadband is still an issue, but so that's one bucket, that data collection. We talked about edge computing as well. I think the second area is data connection. How do you take that data and then share that with other data sets? This is what we need to inform those algorithms for AI, machine learning models. And I think, we talked a little bit about that. Some of the steps in there are the farm management software platforms, of which there are many, but that are currently not seeing the take up that we need. 2, we need these management, estimation, reporting, and verification, the MRV platforms that allow you to actually share information downstream with your partners, so that if you're looking to get carbon or ecosystem service credits, you can get better trade terms with your partners, you can share that information. So that's kind of in the middle there, is all that middleware. If I go back to my days in the mobile space, we had the same issue. We had different operating systems on phones, and all of these data and the apps, they didn't talk to each other. We had hundreds of companies that stepped in and created mobile middleware companies. We need the same sort of effort here to go create that, even for the cotton market. And I think, Larkin, one thing, I think you've said there's only 1,600 cotton gins worldwide. Is that right?
Rob, I think it's fewer now, and I'm not sure the number. I don't want to give a wrong number, but I think it's more like 13 or 14 or 12. Yeah. I mean, it's shrinking.
We've got a lot of people going after the primary commodity row crops, corn and wheat. How do we actually get this to cotton and the rutabaga market, or the Brussels sprout market where I live? My hope is
rice. You can name some of the others that are major minors, sort of thing.
Yeah, and the other thing we already have a number of ontologies. So for instance, there is a cotton ontology, a descriptive language about cotton. There's another one for rice. What I've found through IDEA is there are a lot of academics who have developed these ontologies, but they're not embedded in software. They're not in use in the field or in the supply chain yet. So somehow we need to go get the interoperability of all these different tools. I think I want to get to 2 questions that Russell asked this question about an organization called the Mutual Agricultural Software Alliance. This is yet another organization that I've never heard about. We just ran across another one last week that's in this space, but I don't think that there has been an effort to unify and get the interoperability of a lot of these different groups. The other thing is, Peter asked that question about the industry associations. Are they the ones that should be stepping up? Unfortunately, we've seen Andy and the pork board step in and allow us to get going on pork. I'm asking the same question to the panelists here of how can we get this rinse and repeat? How do we break this cycle so that we can actually take what we're learning from corn, wheat, and get that down to the cotton market, get that down. We have these technologies that should be repeatable. They need to be specialized, but the common elements are there. And how do we break this impasse that we've got right now? I'm throwing that open to the panelists.
Rob, I'll take it up since I work for the trade association. The question was, can industry associations help solve the software problem? The short answer is I don't believe that's their role. What they can do is solve the data problem, the data interoperability, which data should be shared, and if the associations can foster those conversations and help facilitate bringing the people together to have the discussions, because I believe once we get the data sets agreed to and say, oh, good, we're all going to capture and share this set of information by each node in the supply chain, the software will be developed. And we don't need to get into the software development business. But if we can sort out which data those softwares need to use and standardize that, if you will, or at least come up like you're trying to do with the idea group. I think if we build it, they will come. If we sort the data, this software will be developed.
I would agree with that. One of the reasons I picked cotton as my field trip is because it has, in contrast to the grains where they are increasingly commingled through the value chain and there's no identity preservation opportunity at a certain point post delivery to a buyer or elevator. Cotton, the industry has done a good job of creating this unique bale identifier at the cotton gin. And so it's uniquely positioned to, because more information can be attached to that bale than is currently being attached if it was traceable back to production practices or location in a verifiable way. So it's ripe for that, I think, but trade associations, and wisely so, fear, it's my observation, getting into picking winners and losers among their membership. And any opportunity for a premium is also seen as opportunity for a discount. And so offering opportunity for standardization and letting the private market fill the gap on software development is what I have seen most likely.
Yeah, and further to that, I know, Larkin, you had mentioned that, there's a need for on-farm software that does everything for you, so you don't have all these disparate systems. I have heard of a company, and Rob mentioned the Purdue University Open Ag Technology Services Center, and along with Rob, one of the funders or members of that is a company called Centricity. And Drew Zabrocki is the founder of that. And what they did was a number of apple growers in the Northwest in Washington State got together and said, listen, we all have, and they're all competitors, but they said, we all have a need for software that helps us run our business. That doesn't exist today. So what they did was they all got together and they created this company, and they found Drew and created this company called Centricity. That software company is actually owned by a number of growers. And so just kind of throwing that out, that may be one solution of how you address your problem on not having software that actually works for your operations. They were in the same position, and then they all got together, and it's much more efficient for them to do it as a group and have a company and who created software that helps them. And my understanding, it does just about what you're looking for apple growers.
That's a great model. The goal being a development with the farm business management as its primary focus versus selling something to a software program. Well, developers developing it that are in another part of the industry or the supply chain, trying to add a tool to their suite of services for their customers, i.e. farmers, that's just a link to a customer, but it's managing the data probably pretty well for farmers, but also mining the data from the farmers. And that, the whole confidential computing that was talked about becomes very important conversation in some of the licensing agreements for some of the softwares that are available today. And there's some good ones available. They still are relatively focused on one area versus another, but the confidentiality of the grower data is compromised in most of those. And that becomes, an issue.
Can I jump in on the data sharing just a little bit, or the data management or privacy, that whole ball of wax? I think one of the important things is that we focus too much on data sharing, not answer sharing. Fundamentally, what the customer wants to know is, Ed, did you have E. coli on any of your strawberries, right? They want a yes, no answer, and that needs to be verified somehow. But you don't actually have to share the data. And I think there are things like ubiquitous computing, confidential computing, that allow us not to necessarily share all of the data, but just provide the answers to those parties that need it downstream.
Right. And Rob, thanks for getting the ball going with opening it up to the panel. And I'm going to jump in and bring Ranveer into the conversation too. As we were preparing for today, we said many of us are very acutely aware of the problems, and Ranveer especially was helping us get a glimpse at some future solutions. But then we talked about, well, what's it going to take to get there? And we've addressed some of those things today so far, but Ranveer, I don't know if you're still with us, and if you're able to jump in, you had a few other things that you were going to cover in terms of what will it take to get there. So
right, and that is where Shari, thanks for bringing me in. Sorry, my video is I don't want to turn on video right now.
No problem.
But yeah, because I'm on the road and connectivity might be weak. So what I wanted to add to the conversation was that what I've seen in the agriculture sector compared to every other sector is the lack of trust. This thing that Larkin was mentioning as well, that there is that inherent lack of trust in sharing that data. And to some extent, and I get, Rob, your point is completely valid, but the interesting thing is that some of the biggest players are the ones who have most of the data and who are, to some extent, most resistant to share the data. And that's something which we have to but although they realize the benefits of data sharing. In fact, we can think of some sort of a data marketplace that this could enable, that everyone in the ecosystem would benefit from that data. But that is not there yet. And data standardization is one that could help. Data confidential compute and technologies such as that will help. Getting more people trained on data is another thing that would help. And there are a lot of these innovations happening in the tech sector. Like we talked about confidential compute as one example, homomorphic encryption as another. Some of the new things in AI machine learning called federated learning. What federated learning is essentially it's a new technology where you don't need to send all the data to a central place to train the model. Your data could be very distributed, sitting with the growers, and yet you could start training the model in a more distributed way. Federated learning, again, there is no, it's not a scalable product yet. There are a few startups doing this work, but there's a lot of innovative research, and I think that would again help bridge some of the issues around trust that exists in the agriculture and food sector. The other thing is around monetization of the data. I know there are a few companies that are doing very interesting work in this space. Of course, many of you already know about FarmMobile as one, and then there are a few others, which I think is another interesting direction to look at, is how do you incentivize people to share data? And it's not just about a lot of what we are talking about, and also what the Purdue Oats work is doing, Rob, there is mostly around production ag. I think the other challenges throughout the food supply chain and the things that we could be doing across the supply chain to start sharing the data from the farm. That's the hardest bit, but even post that, after it's out from the farm, how do you start sharing the data across the different entities in the supply chain?
Great, thank you. Anybody else have any other ways to help us get there? I think the building trust and the monetization are some of the themes actually in the questions that have been coming in. So I think we'll go ahead and segue to some of those specific questions. On the monetization side of things, we have a question from Steve Coulter with Coke Agronomic Services, both about the consumer side and the farmer side, actually. So he's saying, what do the panelists think if consumers will value the data enough and the transparency and insights that come from the data enough to pay a premium for it on the one side? And then on the other side, how do farmers, Larkin included, how do you weigh the value of that transparency and the willingness to share that data? So on both ends of the consumer and farmer end, how do we get to valuing this? Larkin, do you want to kick off?
Yeah, and I'll take it. And you know, my role here on the panel is supposed to be the farmer advocate. So I don't mean to come across as some sort of protective and defensive farmer, but I think that point of view is, I've been to lots of meetings on data and technology, and I'm frequently the only farmer in the room because the topic is discussed back and forth between software developers and major companies in the food chain or the ag supply chain. And so the perspective I'm trying to bring is, okay, if you're sitting at a lonely desk on a farm, what does this mean to you? So beginning there, to answer your question, Sherry, the value of the, I would hope and think that over time, if there is value to a consumer and some person further down the supply chain, someone closer to the consumer than the farmer, and we may go more direct in the future. The idea of farmers markets is exploding for some of the appeal of that. But if there's value, it will be determined by the market. And for a farmer to capture value, they're going to need to present the data required for that verification. If there is a value to the consumer in a certain production practice or a certain use of irrigation or lack thereof, or a certain use of chemistry or lack thereof, then validation of that to get the premium is going to be required, and the farmer needs to invest in the ability to do so. And so the farmer's motivated in order to seek penetration into specialized markets with special value, if it exists, better data management for on their end of things, and because it's worth investing in.
Thank you. Any others want to respond?
Yeah, Sherry. Will consumers pay a premium for the information associated with the product they're purchasing? That's not a cut and dry answer. If you survey consumers, will they pay a premium? Yes. You'll get the majority. Oh yeah, I'll pay a premium. So I understand that this product is, the companies who've handled the product fit with my expectation of how they treat the people on the planet and what the companies stand for. When it comes down to reality, what our research has shown, many less who said they would, so when you do a survey and 60% said they'd pay a 10% premium for that product, when it actually happens, we find that much less a percentage of people actually put their hand in their pocket and pay for it. I do believe, and there's value in the information within the buying community, and here's what my prediction is: if companies can provide information around the product from the time it's harvested all the way through the supply chain, complete supply chain visibility, and in our world, temperature is critical, and storing and maintaining the ideal storage temperature for each product goes a long way in extending the shelf life and getting the taste and flavor experience that the consumers expect. And if a company buying strawberries, for example, or selling strawberries can prove that from the time these strawberries were harvested, they, within, 58 minutes, they were brought down to the ideal storage temperature of 32 Fahrenheit. and never exceeded 33 Fahrenheit through the entire supply chain, and never got below 32, it's a very tight line, then companies can predict that, or the buyers will know that these strawberries are going to have a superior taste and flavor experience, and they're going to have longer shelf life than product that I don't know what temperature that product was at through the supply chain. And so I think they're more likely in getting a premium from within the trading partners than the consumer. The consumer's a hard sell. It's they'll tell you in a survey they may not necessarily react the same way when especially during the times we're in now, where a lot of people's income has been severely affected by COVID. In more prosperous times, they may be willing to pay a premium. We see it with organic. The desire for organic has, for a number of reasons, the offering's gone down, and people are not as apt to purchase organic right now when their income's been reduced due to COVID.
Yeah, so I think you touch on a point that, well, first of all, there's not one consumer. So when we say, well, consumers pay, there's a lot of segments of consumers. So if it's the 10% that are willing to normally pay premiums for a variety of reasons, it's a matter of if they will pay for it. But Russell Morgan raised that issue of, with the socioeconomic niches and customers, will that be enough for it to succeed? And I think that brings to bear Brian Wee's question about maybe it's not the consumer per se, maybe it's carbon markets that may take off next. And so that's one of the questions that Brian Wee raised was, do you think the promise of carbon markets and carbon pricing might be the way that we can monetize and drive the changes that need to happen to bring this all together?
I'll take that one based on an anecdote of my own life in the last week. I've been in a meeting about carbon on farms and the development of that market. And I said, well, it would be easy for a farm. You just produce your records. And that would, if you produce your records for 3 years of certain practices that qualify for a certain program, easy enough. And other people in the rooms, including farmers, looked back at me and said, Larkin, do you realize how few farmers keep records like that? That's back to my point about the farm-based record keeping system. We've been doing it for a long time, but as technology has evolved, we've actually we've switched 2 different times recently to different record keeping systems offered by different folks that sounded better, more and fancier. And when we found out they didn't work and we switched and went to another one, always painful. Nobody wants to change their IT provider. We lost all the records we put in the system we tried for a while. The stability is not there as this system evolves. This is at the farm level again. And the turn the tap on and it works kind of hope for a farmer by buying a system is a problem. So to your question about carbon, I think it's maybe in the future a driver of better farm record keeping or more accurate farm record keeping and more complete, because if there's value in presenting those records for the first time, separate from your own edification or your own sort of study, I think it may really propel the idea that farm record keeping has value. It will require development of absolutely new skills in many farm operations, both in the field level and at the office level. And my premise is even a new whole consulting band for farmers that's your data consultant, that is an independent, like your independent crop provider. There'll be a whole line of work being a data consultant for farms. That would be one of the things I expect will evolve, especially in certain locations.
Great. I've got a couple more questions that I want to try to squeeze in, but any other responses? It looks like Ranveer took himself off mute. Yeah. Ranveer?
Yeah, Shari, I wanted to talk a little bit about the carbon markets. That is, when farmers do the right thing for the soil, for the environment, they should be paid, especially when there are many other companies looking to offset their carbon credits. And like we announced as Microsoft to be carbon negative by 2030, many other companies have made similar sustainability commitments, carbon commitments. And we are all looking at agriculture as one such way to put carbon back into soil, and for which we need to work with the growers, work with the agriculture companies to put some of this carbon up in the carbon market. But that said, I also wanted to just point out a note of caution here is the debate that's going on around how do you accurately measure in an economical way how much carbon is put back in soil. Right now, just coming up with these numbers is not, is still quite expensive. And there is work going on, there is research going on, there's work by tech companies. We've announced partnerships with Land O'Lakes, with Corteva, where we're looking at these circular economies, working on sustainability and trying to, for example, with Land O'Lakes, working with the TrueTerra platform to see if that can be used through some of the work they're doing on record keeping, and can that be used as part of the carbon models, and can that be used to get some of the incentives back to the growers for using the right agricultural practices to put carbon back into soil. That said, it's still there's still a bit of some open questions here, but if it all works out as expected, then this could be an incentive, and with the other tools that are being developed in this space to enable better record keeping, the thing that Larkin was talking about.
Great, thank you. So I'd like to, as I mentioned, I'd like to squeeze in a couple more questions before we close out, because we have a lot of good questions from our audience here. And the next kind of theme I'd like to bring up is from another one of our roundtable fellows, Jeremy Zwinger, and he's talking about global trade. And we haven't really talked about, we've been talking a little bit more domestically, but how do we take this to the global stage where he believes that, you know, we're further behind at the global standpoint with all the needs there. And Sherry Wise adds to that, you know, how do we tackle the problems of integrating all of this on a global basis? Anybody want to try to tackle that?
In our industry, we don't talk domestically because fresh produce is a global industry. You know, you're getting 50% of the fruit consumed in this country is imported. We export a lot. And, you know, just my organization has members, I think it's somewhere around 45 countries in the world. And they're all trading with each other, and depending on the season, the trade flow goes one way and then goes another. So everything we're doing and everything I'm talking about is applicable to global trade. So if you're selling an apple from South Africa, Chile, or Washington or New York State, the data requirements and what people and what the buyers expect, they have the same expectations no matter where they're purchasing it from. You know, on audits and information and visibility and traceability and, you know, all the data requirements, we don't differentiate. Well, you're not from the US, so that you don't have to do, you know, give me this data. No, it's one standard across the board.
Great, and Rob, I think Rob had something.
Jerry, I was just going to jump in. Country by country, I mean, so it's, you look at, for instance, the Dutch. We talked about our efforts on the pork supply chain. We actually brought in the Dutch, who have already had a project called ePigs. They're farther ahead than us, as is usually the case, right? You look at Australia, they have been much more advanced on interoperable data than we have. I think in part because their country has been on fire and they got big issues. So I think we all have that same challenge of broadband making this work. But I think the other thing I'll say is, in countries that don't have legacy systems, digital systems, there's actually a chance to leapfrog places like the United States, which are somewhat down the road, but not there yet.
And Larkin, you wanted to add before I?
Yeah, I mean,
another question.
The commodity crops that are commingled prior to export pose particular challenges because of any number of producer or production areas can be on a barge load or a ship load of X. And so, you know, they're sort of sold at the lowest common denominator because you can't guarantee any particular quality factor in a hugely commingled #2 corn shipment, for instance. And so if it, and I'm not the expert on this, I'm saying what's common sense. I will say, and I'll go back to the cotton example, by country, the ability, the bale identifier number that I mentioned is a standard in the US. It's not a standard everywhere. So actually US cotton is advantaged over areas where that standard does not exist, because qualities are predictable of our product. Australians have a great system too, but other exporting countries don't. And so differing by commodity, vegetables are an entirely different system, and pork that Rob mentioned, an entirely different system. So I think you can't make a ubiquitous statement about the US being ahead or behind. I think across agriculture, it's pretty specific to the crop.
Great.
Jerry, one more thing, I apologize, but if I look at the most advanced supply chain in the world, it's probably Alibaba's HEMA, H-E-M-A. And if you, I would encourage you, if you got a few 7 minutes or so, go check out a YouTube video on this. But fundamentally, I, as a consumer in their store, I think they've got, thousands of products where you can actually use a QR code and look at the traceability of that product. All the way back to at what temperature was this transported? What was the business license of that farm? And by sharing data with their supply chain partners like Fonterra on milk, the average length of time that a carton of milk stays on the shelf in a HEMA store has gone from 5 days down to 1.
Great, thank you, Rob. I'm going to try to weave together 3 people's questions into one final question for us to address. So this comes from Sanjeev Muhammad Kumar, who's talking about which stakeholders do you think can solve this? That's part of the thread. Alex Eccles from the Campbell Foundation says, how can we establish data standards and who will help establish data standards? And then to weave into that, Peter Arbunkel's question, he's Chief Scientific Data Manager from the USDA. He says, what about a software co-op? Is that the way to go to help solve this? So trying to bundle those 3 together in terms of which stakeholders can help us set these data standards, and is a software co-op the way to go? Rob, I'm looking at you, so I'm going to have you kick off with a response.
I think the software co-op is a great idea. So for instance, we've talked about the Purdue Open Ag Technology Systems Center. They have a trellis framework, which Ranveer, if you're still around, that also does look at food supply chain and goes out to the farm. That's an open source technology, but that doesn't mean that there's no opportunity to make money. Just like Linux created Red Hat, there's opportunities, for instance, for Centricity to leverage that trellis framework and then create services specific to a certain production system or a locale on top of that. And so I'm a big fan. I also think the trade associations could step up on behalf of their members and also fill that role.
I'll echo the opportunity for trade associations to be important voices for their members in this conversation on standardization of data formats. Not writing the software, we've covered this earlier in the talk, but on the needs of their grower group for efficacy and standardization.
And I agree on that. And actually, truth be known, Trellis was created by a committee of the Produce Marketing Association. It's actually, the idea came to me when I was driving in a car in Amsterdam or in Holland with my counterpart over there, Harry Smites, because they had done standardization on lab results and crop results, and I kind of took that idea and said, well, we need to do something like that for audits. So yeah, we definitely have a role within fostering the development of standardization of the data. The other group that we've not mentioned yet, and it's pertinent in our industry, is who's going to help us. It's GS1. GS1 are they're the nonprofit association that manages barcodes. UPC code that you see on every product, that's a GS1 barcode. The traceability labels that we're implementing, and over 4 billion of the 6 billion cases have them of fresh produce, that barcode is a GS1 standard. And no matter what effort we do, we'd be remiss if we did not include GS1 as part of that effort. That's what they do for a living. They standardize data, they develop standard transaction sets, and they're very good. They shouldn't not be leading it, but they definitely should be a participant in the efforts to standardize which data we gather. The other thing, and kind of branching on that a little bit, is, and it's something that Ranveer mentioned, you know, with the sustainability and carbon credits, and Larkin, you mentioned it, if we don't measure it the same way, none of us will be speaking the same language. And if you don't measure it, you can't manage it, you can't profit or do anything with it. And in our world, there is an organization that's been put together, and it's really around sustainability metrics called the Stewardship Index for Specialty Crops. And they set out on a shoestring budget to create measurements. So when we talk about, and they've got 8 or 9 created so far, when you're talking about your water usage, they've developed it with a whole bunch of very smart academics and others. Okay, how are we going to agree of how we measure water usage? They have habitat and biodiversity, energy use, nitrogen, phosphorus, solar, organic, simple, or irrigation, and food loss. They've developed standardized metrics. They're not telling you what the number should be, but what they're telling you is when you're talking about it, here's how you measure that, what the units are, and how you measure those inputs and outputs. And I think that's very important when you're sharing data. You can't have one, for an example, speaking in imperial and someone else and thinking it's metric and or measuring it different ways. We've got to agree what we're measuring, how we're measuring it, and then how we're going, and then the software can figure out how we're going to share it and store it.
Well,
Hey, Sherry, just go ahead, Larkin, please.
I was just going to add and repeat something I said earlier for emphasis. Ed, I agree, and these carbon contracts as proposed when I've listened to it are multi-year events. They could be a decade of a commitment for a farmer in order for the return, or longer. And as such, the record keeping systems need to be consistent for that whole time. I mentioned it earlier. If you see a cool software on your farm and you start putting all your harvest data in it, but then a cooler software comes in 2 years, or an application record keeping management system that evolves that's better, and you switch, in my experience, you lose everything or lose most of the searchability, because if you are a cloud-based service provided by somebody you were paying a fee to manage your data, you no longer have their user interface route to your data in a good fashion. The CSV files that have been downloaded to me have been in terrible shape. So I don't have, for the years that I used a software and then switched, my data. If you engage in a long-term contract and have a record keeping system associated with supplying that information over time, you have to stick with that system or have the data you're putting in be interchangeable with future systems, or you lose the opportunity to verify things in the past. And as technology evolves and as systems evolve, and we've heard from Ranveer how much stuff is coming, let's all be aware that as soon as we swap over to a new programming language or a new system, if we abandon everything in the past in the middle of long-term contracts, it'll be a problem.
Good point, Larkin, and Ed as well. I really like the points that you're raising, and to some extent, that's the way we are thinking of our role as well as a technology company, as Microsoft. As you know, when we build software, we have commitments around supporting it for a certain period of time, and that I think would have a role to play across even over here. If a new company comes up, they need to support all the previous generation of work that has happened. And I think that's what plays also into the role of standards. I think that Rob was mentioning with the Oaths initiative and some of the other work that's happening in this space. We need the standards to come through. We need, and this has happened in other industries and other sectors in the oil and gas sector, where they have come up with a way to store seismic data and send the seismic data to the cloud. It has happened in the telecom sector, the one that Rob was mentioning with 3GPP, with Wi-Fi, where competing companies come together and build standards, and we'll have the same thing here. The challenge here is going to be that
SpaceX too.
SpaceX too. Yes, SpaceX. We announced a recent partnership with SpaceX on essentially providing connectivity to remote parts, to remote areas, including for agriculture, satellite connectivity. That's going to be another key way in which we could address the broadband gap. And as we bring together the companies like SpaceX with the telco companies and the core agriculture companies, as cloud company, as Microsoft, what we are thinking, it's not just enough to build the raw infrastructure, but add those additional pieces on top, like what we are doing with Azure FarmBeats, to bring the different data streams together. And which is where what some of the other key things happening in the tech sector is ways in which you can start making sense of unstructured data, how you can see data and add structure on top. All of these would help. Because to Larkin, your point, a lot of data that a farmer right now stores, as you mentioned, a lot of it is still in notebooks. It's not even digitized. And it's all, even if it is digitized, it's in a very analog format. What I mean by that is that they'll say, I tilled this part of the land, which is very specific to that grower. How do you add structure to that data? So there's some new work happening in the databases community on making sense of unstructured data, which I think would, again, help us digitize a lot of the data that exists, bring it to, like, for the carbon work or for any other AI or any other useful analytics on top. So those are things that are happening, which is, again, I believe some of the things that are needed is all of the sectors would have to come across. It's not just the agriculture and food sector, but all sectors need to come about. And also we need some of the bigger established companies who have the reach to the most growers to also play a role. It can't just be startup led. While startups will be super important to drive innovation, it will also require the existing companies, the large ag companies, the large ag tech companies, the large food companies to participate, to play a role in this as well. And of course, tech and communications companies, including SpaceX and Microsoft.
Yes, well, I'm encouraged that during our discussion, my phone was lighting up and in the chat function about people wanting to collaborate to try to help make this happen. And I think that's one role that Farm Foundation can play in terms of trying to help bring people together to make it happen. So looking forward to what may come from our discussion today. So as we wrap up, I'd just like to say thank you once again to each of our speakers, to Ed, to Larkin, to Ranveer, and to Rob for their contributions today, and for the great questions that came in from the audience. And I'm sorry we couldn't get to all of the questions, but look forward to collaborating with those in the audience and those that have reached out to try to solve this and to have some practical solutions. We'd also love to hear your feedback, so please remember that you can just take a minute for a quick survey at the end. And if there's a spot there, if you want to collaborate, mention it there or reach out to us at farmfoundation.org. So our next forum will be Tuesday, December 8th, and we'll be featuring the perspectives of former Secretaries of Agriculture Mike Espy, Dan Glickman, and Ann Veneman, along with Darcy Vetter, Edelman's Vice Chair of Agriculture, Trade and Food. And they're going to help us set the stage for the next 4 years of ag policy. So we hope that you'll also join us for that. And thank you once again to our audience who joined us and to each of our participants for this wonderful conversation. And we look forward to more to come. Thank you.